Okay, now here in example 4, we're going to move our circle off the origin. Find the standard form of a circle's equation. Write the standard form of a circle with center here at -2, 3 and radius 4. So let's see, our formula is x minus h quantity squared plus y minus k quantity squared equals r squared. So we just want to write the standard form and, get that h and k out of there, replace that with some numbers, and the r will replace with the radius. So let's see, our x value here is a -2, so this becomes x minus a -2 quantity squared plus our y value is a +3, y minus 3 quantity squared equals our radius is 4, so that'll be 4 squared. And here we'll just do some cosmetic stuff. This minus and negative will turn into a plus. So that is x plus 2 quantity squared. The y minus 3 will not change. Quantity squared equals, and 4 squared is 16. I have seen in the past some students, they see that quantity squared and they want to FOIL this out, and they want to FOIL out the y term also. Don't do that. This is our standard form. Because when it's in standard form, it's real easy to see the center of the circle is located here and here, its coordinates, and the radius is given to us also. And it didn't say to graph it up here, but for some reason I included a graph on the in the notes. So let's graph it too. Why not? Center of the circle, -2 and then up 3. And from this point, we have a radius of 4. So I can go 4 to the left, 4 to the right, 4 up, and 4 down. If I connect those dots with something that will slightly resemble a circle, we'll be in business. There we go. Now in example 5, looks like a multi-part here. Use the graph of the standard form of a circle's equation to graph a circle. Oh, and I guess we kind of already did that. Find the center and radius of the circle whose equation is given. Then we're going to graph it and use the graph to identify the domain and range of the circle. Okay, well, let's see here. Back that up. Our formula is x minus h squared plus y minus k quantity squared equals r squared. So let's see, x minus, well, 2 is in the place of the h, so we know our x coordinate of our center is 2. And this is a plus here, y plus 4, when the formula is a minus, y minus k. Well, that y plus 4 is like y minus a -4. And now we match the formula. Y minus k, here's our y minus, that makes the y value of our center -4. Or if you do enough of these, I train myself to just think the sign is sort of the opposite. When I look at this, I see a -2, so my center is going to have an x value of +2. When I look at this, I see a +4, so I'm going to switch that to a -4 when I'm locating the center of my circle. And last, our radius equals, well, this is the radius squared. R squared equals 9. So if we square root both sides, we'll get r equals 3. Remember, you'd get a plus or a -3, but since we're talking a radius is a measurable distance, and that's never a negative number. So we found the center and the radius, just like we were asked to. Here is our center, 2, -4, radius of 3. Part B says to graph it. So center over to 2, down to -4. From that point, our radius is 3. So I can go 3 to the right, 3 to the left, 3 up, and 3 down. And there's somewhat of a circle. All right, now the last part, identify from the graph the domain and range. Well, let's see, our domain is our x-axis, and if I look up, to my x-axis from the farthest left point of the circle, I see -1. And from the farthest right part of the circle, I see a 5. So there's our domain, the set of all x, such that x is in between or equal to -1 and 5. And then our range is on our y-axis. So the lowest point of the circle, I look over and see a -7. Look over from the highest point of the circle and see a -1. So the range is the set of all y's such that y is in between or equal to -7 to -1. And that's part C. Oop, and I guess the book has a picture. It'll be a little better than mine. Get this. There we go. So there's our circle, and they highlighted the axes. You can see for the domain, they highlighted the x-axis above where the circle is defined, and for the y-axis, they did that to the top and the bottom of the circle, where you're defined on the y-axis. And I do see down in the corner there a great question. Let's see how great it is. No, it's just about the signs. What's the bottom line when identifying h and k in the standard form of a circle's equation? It's easy to make sign errors when finding h and k. The coordinates of a circle's center, h comma k. Keep in mind that h and k are the numbers that follow the subtraction signs in a circle's equation. And so here's our x minus 2. The number after the subtraction is 2, so that's our coordinate of our center's x value. And then here we see the y plus 4. We'd got to think about that as a y minus the negative. So the number after that subtraction is -4. So that's our k value, the y coordinate of our center. All right, if we square x minus 2 and the y plus 4 in that standard form in the previous example, we obtain another form of a circle's equation. So here was our form, the standard form from before. If we FOIL out the x minus 2 quantity squared, we get this. If we FOIL out the y plus 4 term, we get y squared plus 8y plus 16, and that's still equal to 9. And then we can get everything on the left and put it in order of descending exponents. So now over here, x squared plus y squared, and then we have our 4x term and our 8y, and then we'll subtract 9 from each side, and that 20 will turn into an 11. The whole thing is set equal to 0. This result suggests that the equation in the form of this, x squared plus y squared, and then you'll have some number times x and some number times y plus a constant, is equal to 0. It can represent a circle. This is called general form. Remember, for lines, we have y equals mx plus b. That's slope-intercept form. But we also had a general form, ax plus b equals 0. In a line, we would take the equation and set it equal to 0 for the general form of a line, and this is also, we can do the same for the general form of a circle. Set everything equal to 0. And that's what they talk about down here in this box, general form of an equation of a circle. It's just in this form. You're going to have an x squared and a y squared. Notice there's no coefficients there. Those have to be 1s. And then you're going to have some number times x and some number times y, and then a constant, all equal to 0. So we can convert the general form of an equation of a circle to the standard form, x minus h quantity squared plus y minus k quantity squared equals r squared. We do so by completing the square. We haven't done that in a while, on the x's and the y's. And let's see how this is done. I'm going to need a little room here. Let's take a little bit. Move this up. So here we have our general formula, x squared plus y squared plus 4x minus 6y minus 23 equals 0. We're going to sort of break this up and get it ready to complete the square on. We'll do our x's first. Here's our x squared term and our 4x. So that's going to sort of be my first part of this process. X squared plus 4x. And then I'm going to leave a little gap here, and I'm going to close that off. And then we're going to look at our y terms now. We got a y squared and a minus 6y. So y squared minus 6y. Again, I'm going to leave a little gap and close that off. And this minus 23, I'm going to add that to both sides to get it out of the way. Now it's over here on the other side of the equal sign. So what we want to do is complete the square here, and then complete the square here. And the little bits we got to add to make that work, we're also going to add to the other side to make our equation stay balanced. So starting here with the x terms. Remember, we did this in class before. I taught you bring down the x, bring down the sign plus, chop this number in half to bring it down. Half of 4 is 2. And then to figure out what's going to work up here, you got to square it when you bring it back up. So 2 squared is 4. I'm going to add 4 to this set of terms. I'm also going to add it over here to keep the equation balanced. All right, on to the y's. I'm going to bring down my y, bring down my minus sign. Half of 6 is 3. 3 squared back up here is plus 9. I'm also going to add 9 to the other side. And that's quantity squared. Now that is equal to, if we add this up, what are we going to get? 27 plus 9, 36. Ooh, 36 is a perfect square. And remember, that's our radius squared. So let me bring the directions back down and see what they wanted us to do. Write this in standard form and graph it. Well, there's our standard form. You know, our x quantity squared, our y quantity squared equal to our radius squared. So there's our standard form. That was part of what they asked us to do. And now they asked us to graph. So we need the center of the circle, and we need the radius. So the center, I see this is positive 2. My center is going to have an x of negative 2. I see a negative 3. I'm going to switch that positive 3 for my center. My radius squared is right here, so if I square root 36, I get 6. That's all the information we need to graph. Center at negative 2 up to positive 3. From there I can go 6 units in any direction. Up 6, that'll take me just off the graph paper. 9 would be about there. I'm going to go 6 over this way, and 6 this way, and down 6 would take us to negative 3. That's a pretty big circle. And excuse my drawing abilities. There we go. And it looks like below we do have a great question. Let's see. Egad, I forgot how to complete the square. Any suggestions? To complete the square on x squared plus bx, take half the coefficient of x, square this number, then by adding the square of half the coefficient of x, the perfect square trinomial will result. You can always look back to section 1.5, those pages in the textbook, or go back and watch my video on that section. All right, some practice problems for you. Pause the video, try them out, and then see how you did. Okay, the first one, we are writing an equation in standard form. When we did these yesterday, we were centered at the origin. Now we are off the origin. So our formula is x minus h squared plus y minus h quantity squared equals r squared. I'm just going to plug in these values. My x is 0, so that's going to be x minus 0 quantity squared plus y minus, our y value is negative 6, and we're going to square that quantity. Oops, and that's equal to r is 10, and that's squared. So the x minus 0, well, that's just x, and we'll square that. Plus, we have a quantity. Minus a negative turns to a plus, so that becomes y plus 6 quantity squared. And that's equal to 10 squared, which is 100. And that's it. They just said write it in standard form. If we had a bigger graph, we could graph it, but that's a pretty big radius. Okay. Number 5. Oops. There we go. Find the center and radius of this circle, graph it, and use the graph to identify domain and range. Okay. Well, for part A, we want to find the center, and that's going to be a point, and we want to find the radius. So here is a plus 3. That means my center will have a minus 3, and there's a minus 1, so my center will have a plus 1. This is my radius squared, so if I square root it, I get a 2. And let's graph it. Center's at negative 3, up 1. And from there, our radius is 2. Down 2, left 2, up 2, right 2. There's our circle. From that, we will identify the domain and range. So let's see here. Domain is my x-axis. Looks like the domain goes from negative 5 to negative 1. And our range would be on the y-axis. That goes from a height of 3 down to negative 1. And let's have a little fun, and we could do that in, well, we did it in set builder in the example. Let's do it in interval notation. Our domain would be all the numbers from negative 5 to negative 1. That's on the x-axis. And our range would be from negative 1 to positive 3. And I guess we could double check that. This should be the distance between our endpoints on our domain and range. From -1 to -5, that's a distance of 4. And from -1 hopping 0 over to +3 is also a distance of 4. Okay, the last one, we're going to have to do a little complete in the square. They gave it to us in general form. They want it in standard form. And they're going to have us graph it at the end there. So let's get everything set up. I'll separate my x's and y's. So I'll have my x squared plus 4x and leave a little gap. And then I'll have my y's, y squared minus 4y. And that's equal to, I'll add 1 to both sides. So I have a 1 over here. All right, let's set up our empty binomials. That will be quantities squared. And we bring down the x and the plus, and we bring down the y and the minus. And then this number chopped in half is 2, and we square it and add that over here. So I add it to the other side also. Same song and dance here, same 4, chop it in half for 2, bring it back up and square it, so we're going to add 4 again to both sides. I shouldn't have put this 1 here yet, because I know now that 1 and 4 and 4 add up to 9. So there's our standard form, and they would want us to graph it. So to graph, we're going to need to know our center and our radius. Well, the center is going to be -2, comma, +2. And this is our radius squared, so the square root of that is 3. Graphing now should be a piece of cake. Center's at -2, +2. And from there, our radius is 3 in any direction. Up, left, down, or right, 3 units. And you get the idea. Okay, some homework to have a little fun with circles.